So, area formulas, little review. Definitely need your calculators because, like I said, there'll be some SOHCAHTOA and whatnot coming up in this. Find the radius of a circle with an area of 36 square feet. Round to the nearest tenth. So, of course, this is on your formula, your little video. Area of a circle. I'm just going to jot down the formula so it's in front of us. Tells you the area is 36. We'll put that in for A. Pi just is pi. Pi, of course, is just a number. And, of course, we're trying to find the radius. Now, you are going to need your calculator here, my friends. But to get the radius alone, I'm going to get first rid of the pi. So I'm going to divide each side by pi. So in your calculator, you need to type in 36 divided by pi. Now, just to show you too, because I've got my graphing calculator up here, there is a pi button on here. I know we all know pi is about 3.14. Can you just use 3.14? Sure. I like to do it as accurate as possible though, so I'm actually going to use the pi button. So I'm going to pull that up so it does all the value. I'm going to round that, what does it say, to the 10th, so I'm going to go 11.5, give or take. Okay, last step, how are you getting rid of the squaring? Square root it. Now, and just to show you this too on your calculator, because there's a lot of calculator stuff today. So I know I need to square root that answer, so of course I'm going to pull up my square root. Now, if I want to make this super accurate, I don't want to type in 11.459, that's obnoxious. If you hit second negative key, it automatically pulls up that previous answer. I don't even have to type a thing. 3.4, done. Okay? So just to kind of show you that on your calculator if you did not know. I'm going to get fancy, put a label. We're in feet.
Wait, so it'd be wrong if you just typed in the square root of 11.5?
No, you can still do it. Your decimal point, though, your after the 10th might be a little different, though.
Okay.
Yep. Not wrong, not wrong. I just try to keep mine as accurate as possible. Okay? All right, find the area of the shaded region. I'm just looking to see how well that copied, if you can see the shading. So, all right, I think we get. So first, we have two different figures, two types of figures in this picture. We have the overall square, so I'm going to start with that. So I'm just going to do area and just to label it, I'm going to say the square. And then we'll talk about all the little circles. Now, we know area of a square, side squared, length times width, base times height, all the same. We're going to do 20 times 20. 400. I'm going to put inch, I'm going to label it inches squared. Then we have the circles in there. Let's do that. Area of the circle. So let's talk about those. Of course, pi r squared is our formula. So we have to do a little investigating here and figure out the radius. Well, notice they have these marked congruent. So I'm thinking about, of course, another radius. Kind of draw them in. So really going across left to right, there are 1, 2, 3, 4 radii. And they're all congruent. So total across is 20. I'm going to evenly divide it by 4. 20 divided by 4 makes the radius 5. 5 plus 5 plus 5 plus 5, 20. So I'm going to use, for my radius, 5. All right, we are going to punch that in the calculator. So again, I don't care if you just use 3.14. I always try to actually hit the pi button so it's as accurate as possible. I'm not going to type 5 squared. I know 20. So I get about 78.5. Let's round to the 10th. Now, here's a quick question for you, though. How many circles are in the picture? This is an easy question. How many circles are in there? 4. So I'm going to times that by 4 for all the circles. All right, so let's punch that in. Then I'll label it 78.5 times 4. And we get 314. That's kind of nice. 314 inches squared. Now, final little fun fact here. We want the area of this shaded region. So we have one last calculation to do. If the entire square is 400 and the circles are 314 total, how are you going to figure out what's left for those little shaded regions? Subtract. So I'm going to do 400 minus 314. All right, so what is 400 minus 314? 86, and I'm going to label it inches squared. So just kind of a combo lesson of reviewing area of a square, area of a circle, putting it all together. Today we're going to talk about area of regular polygons. Brand new, haven't done it, new formula for you, all sorts of good stuff. And we are going to practice this again when I see you on Friday, the next day. All right, let's get into what a regular polygon and all this vocab. There's nothing to fill in on your sheet right now. You just need to look at this, because these figures come up in other figures, some of the three-dimensional figures later in the chapter. So regular polygon. The center of the regular polygon and the radius of the polygon are the center and radius of the circumscribed circle. Now that sounds crazy. First up, regular polygon. They're all the same measurement on the sides. They're all congruent. Everything's congruent. That makes it regular. Circumscribed in a circle just means clearly the circle goes around the outside edge. Now, vocab, some things we're going to use here today. You might want to highlight this. We're going to talk about this word a lot. The apothem. That's how you say that, apothem. The distance from the center to any side of the polygon. So this here in red is the apothem. We are going to need that today in one of our upcoming formulas to calculate the area of a regular polygon. So just FYI. And it's any of these, from the center to the edge, center to the side. I mean, I could draw on all of them. I don't know if we really need to see all of that. But any center to the side is the apothem. Now I'm just going to scroll this down a smidge. Mine's off the screen. Yours is on there. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices. So you know what central angles are? Vertex on the center. So this, of course, would be an example of a central angle. Vertex on the center. To find the measure, now this is the key. You might want to highlight it. Notice it's like in bold italics on your note sheet. A full circle is 360. You know that from last chapter, the gift that keeps on giving. So to find the central angle, you divide 360 by the number of the sides. We're going to need central angles today. So if let me erase, I have so much stuff drawn on here. So if I needed a central angle, let me put that back on. Come on, smartboard. So if I needed the measure of this central angle, I'm just going to call it x. I'm going to do 360, and I'm going to divide by how many sides? 1, 2, 3, 4, 5, 6. What's 360 divided by 6? 60. So all of these central angles, if I drew them all in, would be 60. They all would total you to 360. Clearly, I just draw them all in. So that is going to be important when we go through to find our area. So before we get to the area formula, let's just kind of practice this angle, apothem, etc. No calculations yet. In the diagram, A, B, C, D, E is a regular pentagon. Regular, everything's congruent, inscribed in the circle. Find each angle measure. So the first one they want, A, F, B. So they want this, mine's in red, the central angle. So that's what we just talked about. I'm going to take 360, the full circle, and divide by the number of sides. Well, how many sides are on a pentagon? 5. So punch that in your calculator with 360 divided by 5. 72. So all the central angles are 72. I could draw them all in, but I don't know if we really need to see that. Next, B, the measure of AFG. So we're going to need this guy. You need, I'm going to give this away. We need half of the 72. Half of 72. 36. And I mean, clearly, I don't expect you to show work for that. You can just do that in your calculator. All right, measure of angle. We'll do this one in blue. GAF. Well, we know 2 out of the 3 angles in a triangle. Previous knowledge. All 3 angles in a triangle add up to what? 180. So remember, we just said that this guy, I'm going to write it in green, is 36. I'm going to try to sneak that in there. I know it's messy. You've got your right angle, 90. So we need this missing blue one. So I'm just going to do 180 I'm going to take off the 90, you do that in your head, and then we'll take off the 36. So what do you get for a final answer there? 54. Okay. So the new important piece that we have to use in this upcoming area formula is this central angle. We're going to divide by the number of sides. You get two right triangles. Remember I said Pythagorean theorem, SOHCAHTOA, all that stuff. Two right triangles. We're going to use some of our right triangle knowledge for these problems coming up at us. But we're not there yet. Let's just practice some more. In the diagram, WXYZ is a square inscribed in the circle. Identify each of the following. Okay, vocab, let's do it. What do you got for a center? P. How hard is that? There's a couple radii in here. Give me a radius. P to Y, P to X. I'm going to put a segment symbol on them. Now, quick question for you. Is PQ a radii? No, because Q is not on the edge of the circle, so be careful there. All right, apothem. Now, I'm going to do that in green since that's our new exciting thing here we're going to use today. Apothem, remember, goes from the center to the middle of a side. So what's the apothem? P to Q. I'm just going to put an A to label it. Okay? Okay, central angle. Well, we've been doing central angles forever. Vertex on the center, I'm going to do it in blue, and it goes, of course, with two radii. So I'm going to name this angle XPY, YPX, however you want to do it. I didn't just use P because, I mean, is it these little angles, the whole thing, whatever. I used the 3 letters to make sure I clarified it's all 3. All right, now we got to answer this other stuff. Find the measure of each of the following. Well, they want XPY. So central angle, same thing we did on the last problem. A full circle is 360. We're going to divide by the number of sides on our figure. I mean, it's a square, there's 4. Got it? So my central angle is 90. Okay, next up. Measure of angle XPQ. Well, if the whole blue central angle was 90, how much is half of it? 45. So I just did that in my head. 45, half of it. Got it. Okay, final one. I'm at the very bottom. PXQ. PXQ. Don't overthink it. We have 2 out of the 3 angles in a right triangle. It's a special right triangle. 45, 45, 90. I don't even have to do the 180 deal. So just practicing our vocab, getting our central angle, that is the key. We are now ready for our formula we're going to be using, because we're going to do the area. Now, there's a lot of stuff on here. Just wait a minute. I'll tell you what to write. Area of an n-gon. You can find the area of any regular n-gon by dividing it into congruent triangles. I'm not going to bore you with going through all of this crazy area of the triangles. It's the bottom formula that counts, which is at the bottom of the screen, so I'm going to write it up here. So where on your notes it says area equals, you are putting 1/2 P, capital P, make a capital P, and a little a. So that's what you're filling in on the area formula. That's what we're going to be using. You will get that on your formula sheet. Now, what do those mean? The little a is that apothem. And you can see on the picture, you got the a on the picture. Now, what does the big P mean? Because you're going to need this calculation, obviously, today. Perimeter. How do you find perimeter of any figure? How do I find perimeter? What do you do to all your sides? Add them up. So if you're like, oh gosh, I forgot perimeter, make yourself a note. You're going to add all sides. But I hope we know what perimeter is. All right, we are ready to do what we're actually working our way up to. Finding the area. We already wrote the, okay. Find the perimeter and the area of the picture. So first off, we're working on our new lovely formula. So I'm going to start with that. Now, I'm looking at the picture. I need perimeter and apothem. They gave me one of those. I'm super happy I got something. They gave you the apothem. From the center to the edge is the apothem. So I know little a is 6.5. So I know I'm going to put 6.5 in for a there in my formula. I'll do the rest in a minute. The problem is we need the perimeter. So that's what I'm going to work on. Because here's the glitch. Yeah, I know the radius is 8. That's super duper exciting. I don't know any of the sides. I need the sides of the picture. Clearly, you have a right triangle. I want to know this missing side. When you know two sides of a right triangle, what exciting theorem can you use? Starts with a P. Pythagorean theorem. Side squared plus the other side squared equals my hypotenuse squared. Remember, hypotenuse is the longest side across from the right angle. All right, clearly this is a calculator issue. So let's punch in 6.5 squared. Fire up the calculator, 6.5 squared. So let's hit enter maybe. Oh, it did. So 42.25, or if you round it to 42.3, that's fine. Now here's the thing too, is you're checking your answers. If you round anything a little different, what's after the decimal point might be off. Am I mad about it? No, I'm not mad about it. But if you round this to 42.3, your answer might be a little off from mine. Fine, I don't care. All right, I'm going to subtract that off of 64, which I'm just going to do in my calculator, because I'm guessing you guys already have this done. So I have x squared equals 21.75 into, there we go. How do you get rid of squaring? Square root. I'm just going to square root it in my calculator. I'm going to pull up that previous answer because I'm too tired to type it in. I'm going to go, let's go 4.7, let's say. So I'm just going to put on the side here, x equals 4.7. So that is this guy. So my next question is, I need the perimeter of the whole darn figure. So we've got half of a side, 4.7. What is one complete side? 9.4. Because of course these are the same, you're going to add them up. So each side is 9.4. What's a quick, easy way to do the perimeter? Because I do not want to type in 9.4 plus 9.4 plus 9.4 plus 9. I don't want to type that in. How can I do it quick? Times 5. There's 5 sides. Punch that in. What's your perimeter? 47. Got it. Now I am ready to get my final, I'm going to back it up, final area answer. 1/2 times the perimeter, we just got 47, and they gave you the apothem. Punch that in. What's 1/2, or 0.5 if you like, 0.5 times 47 times 6, this is a decimal, my sloppy writing, times 6.5. What do you have for the area? Final answer, 1.
52.75.
I'm going to round it to 0.8. If you want to leave it 0.75, I don't care. Now, it's not feet or inches or centimeters. I like a label. Okay, again, I'm not going to be totally upset if you don't label. When there's not a label, I just go generic. Units squared. I care more about that you have the 152.8. All right, next up, my friends. Find the perimeter and area of the polygon. Same thing. So I'm going to jot down the formula, half PA. And I'm taking a look. Let's first see what we've got. They give you the 7. All right, I like the 7 because you know what? It's regular. All sides are 7. So I can pretty easily get your perimeter. How many sides are on this picture? Count it quick. 10. So in your head, what's 10 times 7? 70. Okay. So I've got the 70 for the perimeter. So obviously the next problem on this one different. They didn't give you the apothem. The last problem, did. This one doesn't. So we're going to talk about how to find that. So first, I'm going to draw in, wherever you want, a central angle. Oh God, that looks about the middle. And we're looking for a right triangle. Now, I don't know, I'm just going to draw into the bottom here. So the first thing I'm going to do, because it's all going to turn into triangles, you could draw any of the triangles you want. I did the bottom because I don't know, I felt like it. Is I want this central angle. So I'm going to do that 360. And you told me there were 10 sides already. We don't need to recount. 10. You can do that in your head. What's 360 divided by 10? 36. So each central, this green angle, is 36. Now, I want a right triangle. I want the apothem that goes from the center to the edge. So I'm going to draw that in. So this red part is the A. Now, that's tiny. I'm going to redraw this triangle bigger just so I can not make a giant mess out of it. So I just am redrawing it so it's a little bigger, so I got room to write here. Here's the thing, I need an angle measurement. If the green central angle was 36, how much is just this right half? 18, we cut it in half. Okay, now you also know the full side is 7. What's just half a side then? 3.5. So this is, I don't expect you to do this every time, but I always redraw out the triangle bigger so you can see it better and I'm not making giant mess. It's hard for me to write all those little numbers in there. The key is we have to find that A. Here is a throwback to chapter 9. Not a special right triangle. I can't do 30, 60, 90, 45, 45, 90. So my only other choice, I am back to SOHCAHTOA. Yes. Okay, SOHCAHTOA, here we go. Sine, cosine, tangent on the calculator. Now, label your sides from the angle. Straight across is our opposite side. Next to the angle is adjacent. So I'm looking for opposite adjacent, tangent, TOA. So I'm going to jot it down over here. I'm going to do tan of 18 degrees equals the opposite side over adjacent. Now I'm going to do the algebra to solve that. As always, I'm going to clear the fraction. And then to get A by itself, I'm going to divide by tan of 18. If you're like, oh man, I hated this stuff, it's coming back at us hard this chapter. Just to warn you. Okay, so in my calculator, before you type it in though, hang on. I'm going to type in 3.5 divided by tan of 18, but I don't even know if mine's in it. Make sure your mode is in degrees, not radians. You might have done something in a different class between now and when we did this. Make sure in your graphing calculators it says degree at the top. If you have a scientific, it might say DEG somewhere. Make sure you're in degrees. I already forgot what I'm typing in. 3.5 divided by tan of 18. Divided by tan 18. Okay, let's round it. Let's go 10.8. If it doesn't specifically say what to round to, I go to the 10. So now I'm ready to finish off this area formula. I'm going to put 10.8 in there for A. So now I'm going to do 1/2 times 70 times 10.8 for your final area answer. What's your final area answer? Punch it in for me. You got it. Now I'm going to get fancy on it. I'm going to put units squared. Again, I care more about the 378 than I do the unit squared, obviously. So a little bit of work today on the SOHCAHTOA. You're going to have to be using that again. All right, one more. And like I said, we're going to practice these more on Friday. So never fear. Find the perimeter and area of the polygon. Same thing. Half PA. I always like to jot the formula down. Now, let's take a look at what they gave us. This 5. Is the 5, you got a 50-50. Is the 5 representing the side or the apothem? So that's a win. So I'm going to put 5 in. So clearly I'm working on the perimeter. Okay. So we need a side, right? So as always, I'm going to make my right triangle. From the center, I'm just going to connect it. Now, so I don't make a giant mess, I'm just going to redraw it out a little larger for us. So we got 5. So we need some angle measurements. So we're going to do that central angle trick where I take 360 and divide by the number of sides. How many sides are on your triangle? All right, 360 divided by 3, 120. Now that's the whole angle. What's just half? 60. And we need sides. I need this bottom of the triangle, so I'm going to put X here. You have a choice how you want to do this. I could do SOHCAHTOA again. Totally legit. Opposite, adjacent. I could do tan. Tan is 60, X over 5. Or you could remember your 30-60, your 30-60-90 shortcuts. I can do this one with no work. You know the short side is 5. Do you remember how to go from the short to the long? 5 square roots of 3. 3, I hear it, questionable. And then I just punch that in my calculator to get a decimal. That's about 8.7. Or, like I said, you could do tan is 60, like I did on the last one, equals opposite over adjacent. You could do the same set. If you're like, oh my God, I don't remember the shortcuts, don't use them then. Use SOHCAHTOA. I don't care. And you will get 8.7. Okay. Now, so getting into this perimeter. So let me ask you this question. Just this half, there's my key, half is 8.7. What's the full side? We got to double it. So now you can do your perimeter. There's 3 sides on the triangle. They're all 17.4. And again, I'm not going to do 17.4 plus 7. Oh, that's stupid. We're going to do 17.4 times 3. So what's your perimeter? What do you have for it? I like it. Now I'm going to back up the truck. I'm going to put my 52.2 in here for my perimeter. Maybe space that a little bit better. Yeah. Okay, so what's 0.5 times 52.2 times 5? I'm just going to round it 130.5. Label, generic. Yeah. So I'm going to be perfectly honest with you. This formula comes up again later in the chapter, so it's super important you can do these regular polygons. Hence why we're going to practice again on Friday. Now, for your homework,